And welcome back. Now let's see some examples and actually make you do some work. So let's actually think about how to calculate some floating point back and forth from floating point to decimal and back. So here we go. First quiz, pause the video. What's the decimal equivalent of 1, 1,000, 1, and then 3 ones and that? Go. Pause the video. And welcome back. See, I've kind of froze there, like I was kind of pretending like I was frozen. Okay, let's do this together. All right, well, first of all, I see a 1. I think it's a negative number, but I don't know. The other part always confuses me. Let's go. So I first label them, sign, exponent, significand, first thing. Okay, here's my equation. I pull my equation out. Minus 1 to the s, it can be a negative number. 1 plus significand, so it's 1.111 already, times 2 to the exponent minus 127. Okay? So, first one is, what's the exponent? Well, that's 128 plus a 1 is 129. 129 minus 127, we're going to see that is minus, that's 2, sorry, that's 2. So 1.111 times 2 to the 2 means I move the binary point to the right 2 spots. So that gives me minus 111.1. Now you probably, I hope you can do this one from here. This is like fixed point, which says minus 7.5. Not bad, okay? So that was a great explanation of how to do that with simple numbers. We don't like to have a lot of energy in the significand. That's just too much work, but that's the basics of it. Pretty cool. Next one, how would you represent 1/3? Wait, what? This is repeating, yeah, it is a repeating fraction. So in base 10, it's a repeating fraction, 0.333. So let's actually start. Well, is there any halves? Nope, there's no 0.5s in there. Is there any quarters? Yep, there's 0.25. Okay, subtract that off. What are you left with? Okay, keep doing this, and you'll see that it actually works out to be, it's a quarter, not an eighth, plus a 16th, plus a 64th, and so you'll see that it actually is a quarter, a 16th, a 64th, 256. It actually skips one. It starts by skipping 1 at the half, and then every other one. That's it. So now we can do it. If we know that, we kind of do a couple of them, and now we can actually do it. So 2 to the minus 2, 2 to the minus 4, 2 to the minus 6, 2 to the minus 8. Or, let's write it here, 0.010101, et cetera, times 2 to the 0, because I don't need to move that or shift that at all, okay? So that's pretty cool. So now, what's that really when I normalize it? Remember, I have to normalize it. That becomes 1.01010101 times 2 to the minus 2, okay? Because I had to shift the binary point to the right. So now 2 to the minus 2. Now you say to yourself, how do I store both that exponent and the significand in there? Sign's 0, it's a positive number. Exponent is, I got a minus 2 plus the 127 to get 125. So the bit pattern has to say 125. And actually, it's kind of interesting. If you look at the bit pattern 125, how many here am I missing? This looks pretty. How many am I missing from being all ones? Well, it's really here. I'm missing a 2. So you can kind of figure out quickly, minus 2, I know that I'm 2 off of that, which is 125. Because I'm missing the 2's bit, okay? Significand, but I'll say that another way. 127 is 0 and all ones. Minus 2 says minus 2, which is why there's a hole here. And that 1 minus 1 is 0, and that's what that hole is, just to make sure that is. Significand is 0, 1, 0, 0, 1, so I'm left with this bit pattern, and that is a third. Kind of a neat bit pattern. All right, so let's see if we can actually understand the significand a little bit better. And remember, I mentioned this a couple of videos, but I want to be clear about it. 0.34, if I give you that some decimal back in there, you can say, 0.34 is really like, 0.340. It's like having 340 over 1,000, or it's like 34 over 100. So it's 34 hundredths. That's another way to say that. Same way, 0.110, let's think about that, 0.110, that's like saying 6 over 8. I had 3 bits for the 8, 6 over 8. Or 3 over 4. Same thing, 0.11 over 100. So this is nice, people like this way of thinking about the significand. There's another way of doing it, which is you just add up the pieces of it. We saw add up the place values. So if I have 1.6732, it's really like 1 ones, 6 tenths, 7 hundredths, etc. So 1.1001 is another way of saying it. Well, I have 1, 1, 1/2 and 1/16. So I can either think of this number as 9/16 or 1/2 plus a 16th, which is 9/16. So the two ways of thinking about this, please choose the one that's more appropriate for you, that kind of makes sense for you as you're thinking about these numbers. But that does help to be able to work with binary points on the fractional side, kind of in a fixed point way. All right? See you in the next video.